SQL injection concepts. This topic explains how attackers exploit vulnerable input fields to manipulate back-end SQL queries. It's like sneaking a special note into a restaurant order to secretly tell the chef to cook something else. In web security, SQL injection reveals how improper input validation can expose databases to unauthorized actions. By inserting SQL payloads into fields like login boxes or search bars, attackers can extract data or modify operations. Our goal here is to understand how this attack manipulates queries to breach database logic. We'll use a web-based vulnerable app to demonstrate an SQL injection attempt on a login page. The tool sends crafted input that changes the SQL query structure and bypasses authentication. The output reveals login success without valid credentials, showing the query was hijacked. Attackers gain unauthorized access or dump sensitive data. Defenders must sanitize inputs and use secure query techniques like parameterized statements to prevent this risk. Types of SQL injection. This topic explores different SQLi techniques used to exploit backend query flaws in web applications. It's like using different keys, some brute, some clever, to unlock the same door. Understanding SQLi types helps defenders detect and mitigate each variant before real damage occurs. Common types include classic, blind, error-based, union-based, and time-based injections. The objective is to distinguish these methods and see how each manipulates SQL responses differently. We'll simulate several types against a test login field to observe how behavior and outputs vary. Each technique alters the query uniquely, either extracting data, triggering errors, or confirming logic through delays. From revealing full tables to just confirming a condition, each form reveals insights about the backend logic. Knowing the differences helps security teams apply tailored defense mechanisms, from error handling to query hardening. SQL injection methodology. This topic breaks down the systematic process attackers follow when exploiting SQL vulnerabilities. It's like solving a combination lock, one dial at a time, testing each move carefully. The SQLi process starts with detection, then moves through enumeration, exploitation, and finally data extraction. Each step involves strategic inputs to probe and understand how the SQL backend reacts. In our hands-on, we'll attempt login bypass, confirm injection points, then extract user data. Using a vulnerable app, we'll begin with basic payloads, escalate to union queries, then enumerate database contents. Each result gives us more information, schema names, table data, or hidden fields, confirming control over the query. This structured approach allows attackers to move precisely. Defenders must understand each phase to monitor, detect anomalies, and shut down SQL injection pathways before damage occurs. SQL injection tools. This topic focuses on automation tools designed to detect and exploit SQL injection vulnerabilities. It's like using a metal detector to sweep for hidden mines, fast, efficient, and precise. Manual SQL injection is slow and error-prone, but tools streamline detection, payload testing, and data extraction. The most widely used tool for this purpose is SQLmap, an open-source CLI scanner. In this exercise, we'll use SQLmap to test and enumerate databases on a vulnerable web parameter. The tool scans the target, detects injection points, then automatically retrieves backend database names. The output confirms SQLi vulnerability and lists accessible databases, a critical initial step. Automated tools save time and increase attack surface coverage. Security professionals also use them to audit applications during assessments and proactively identify injection flaws. Evasion techniques. This topic reveals how attackers bypass SQL injection filters using encoding, comments, and syntax tricks. It's like disguising your message in invisible ink to fool a security guard reading your note. Modern web apps may block known SQL payloads, but attackers use evasion to sneak past detection layers. These include alternate encodings, whitespace manipulation, inline comments, and logic obfuscation. Here, we'll simulate filtered input fields and inject obfuscated payloads that bypass input validation. Using various encoding and injection tricks, we'll test if the app still accepts and processes queries. The result shows even filtered forms may be vulnerable, depending on how they parse or sanitize inputs. For attackers, evasion increases success rate. For defenders, it highlights the need for proper query binding and behavior-based detection, not just string filtering. SQL injection countermeasures. This topic focuses on defense techniques to block unauthorized SQL query manipulation in applications. It's like sealing a vault and only allowing access through a secure, guarded window, no direct keys. SQLi remains one of the top web threats, so mitigation must be layered and strict. Key defenses include input validation, query parameterization, and using ORM libraries securely. We'll walk through best practices used by secure developers and security auditors to prevent SQLi flaws. These techniques ensure user input doesn't directly modify query logic, blocking malicious payloads. The key outcome is safe, predictable query behavior even under attacker input, no injection success. This protects data integrity, prevents breaches, and reinforces trust. Whether writing code or auditing apps, understanding these countermeasures is essential to harden systems against SQLi.